Hey guys, welcome to the Tiny Maths channel. I'm here to help you on your journey to better maths, one step at a time. Today we are learning about prime factorization. Prime factorization is where you take any positive number and write it as a product of prime numbers. When we do this, we call the prime numbers prime factors. Here are a few examples. Take the numbers 8, 15 and 60. To rewrite these numbers in prime factorization format, we get 8 equals 2 times 2 times 2, 15 equals 3 times 5, and 60 equals 5 times 2 times 2 times 3. The numbers on the right hand side of each of these equations are factors of the original numbers on the left hand side. Notice that on the right all the numbers are prime numbers. So since they are prime numbers and are factors of the left hand side numbers, we call them prime factors. We will be learning how to write numbers as products of prime factors, so they will be in prime factorization format. So stick around and you see how I turn these three numbers, 8, 15 and 60, into these products of prime factors. To get the most benefit out of the lesson, you need to know how to find the factors of positive numbers. We'll talk about finding factors in a moment. You also need to understand prime numbers. If you need a refresher, I've made 2 previous videos in this series explaining prime numbers. The first video explains what primes are and how they differ from other numbers. And the second video explains an easy way of finding the prime numbers between 1 and 100. I'll link to the video in the description and at the end of this lesson so you can watch them afterward. Now here's a quick example of how factorization with normal numbers works. Take the number 8 for example. First, find all the numbers that divide 8. They are 8, 4, 2 and 1. These are called the factors of 8. Now to factorize the number 8, you need to find pairs of its factors that, when multiplied together, give the number 8. The most obvious pair is 1 times 8, but there's another. You can also use 2 times 4. We call these factor pairs of the number 8. 2 times 4 equals 8, and 1 times 8 equals 8. You have no other factor pairs of 8. 8 times 4 doesn't work, neither does 8 times 2, nor 4 times 1, nor 2 times 1, because their product is not 8. So the factorization of the number 8 with normal numbers looks like this. 2 factor pairs. Do you remember how the number 8 looks in prime factorization form? We get 2 times 2 times 2. So the number 8 can be expressed as either 1 times 8 or 2 times 4 in normal factorization, or 2 times 2 times 2 as prime factorization, where all the factors are prime. You can express the number 8 in 2 ways with normal factorization, but only in 1 way with prime factorization. Look at the factor pairs of 60 now. There are 6 of them. So we can express 60 in 6 ways with normal factorization. But in the prime factorization of 60, we only get 1 way. 5 times 2 times 2 times 3. This is true for any number. There's always just one unique set of prime numbers in the prime factorization of a number. So let's see how we turn the numbers 8, 15 and 60 into prime factorization format. We'll work on the number 8 first. First, pick any of the factor pairs of 8. Let's start with 4 times 2. Now 2 is prime, so let's mark that as complete, because we're looking to break 8 down into only prime factors. Now 4 is not prime, so we want to break 4 down into factor pairs and keep going until we only have prime factors. To do that, we'll find the smallest prime number that divides 4. Remember, if a number divides 4, it is a factor of 4. Well, 2 is the smallest prime number and it also divides 4, so 2 is a factor of 4. If you want a factor pair of 4, we have to find another number which, when multiplied by 2, gives the number 4. Well, the only number that allows this is another 2. so the factor pair of 4 will be 2 times 2. Now, both of these numbers are prime, and so we mark them as complete. Since prime numbers cannot be factorized any further, see my videos on primes to understand this, we can't factorize the numbers we have circled as complete any further. Now we just multiply all the primes we encountered. That's 2 times 2 times 2, which equals 8. And we have the prime factorization of 8. Let's work on 15 now. The numbers that divide 15 are 15, 5, 3 and 1. These are the factors of 15. And the factor pairs we can use to make 15 are 1 and 15, that's 1 times 15, and 5 times 3. This process is quicker if you try to select factor pairs that already have at least one prime, because some of the work is already done for you. So let's take the factor pair 5 and 3. Well, in this case, both 3 and 5 are prime, so they are already prime factors, and there is nothing to do but multiply them, giving 3 times 5 equals 15. So 3 times 5 is 15 expressed in prime factorization format. Let's tackle 60 now. Why don't you pause the video and try this one for yourself? And while you're trying to figure it out, why don't you smash the subscribe button and like the video. Hopefully the algorithm will promote Tiny Maths videos to more students needing math help. So here are the factor pairs of 60 again. I'm going to choose 5 and 12. 5 times 12 equals 60, so we know it's definitely a factor pair of 60. 5 is prime, so we mark it as complete. 12 is not prime, so we look for the smallest prime that divides 12. 2 is the smallest prime, and it can divide 12, so 2 is a factor of 12. To complete the factor pair, we need another number which, when multiplied by 2, gives 12. 2 times 6 equals 12, so 6 is our other factor in the factor pair of 12. But 6 is not prime, so let's mark 2 as complete and continue working on 6. Again, we find the smallest prime number that goes into 6. Well, that's 2, so 2 is a factor of 6. And to complete the pair, we need to see which number, when multiplied by 2, gives 6. Well, that's easy. It's a number 3. 2 times 3 equals 6. So our factor pair of 6 is 2 and 3. 2 and 3 are prime, so they are prime factors of 6. And we can go no further. Mark them both as complete, and now we multiply all primes that we encountered. That gives us 5 times 2 times 2 times 3, which equals 60. So that's the prime factorization of 60. What if I chose another factor pair? Would that give me a different set of prime factors? Well, look at 4 times 15. 4 times 15 equals 60, so 4 and 15 are a factor pair of 60. We already saw that 15 equals 3 times 5, and 4 equals 2 times 2. So really, 15 times 4 is the same as 3 times 5 times 2 times 2, which is just 5 times 2 times 2 times 3 with the numbers rearranged. It's exactly the same set of prime factors. So yes, there is only one way to write 60 in prime factorization format. Try other factor pairs of 60. You'll find you will always get the same set of prime factors. So there you have it, the simple steps to prime factorization. The next video in this series will be on how to find the highest common factor of two numbers using prime factorization. Also, I'll be covering many other subjects at the high school level. So, if you find lessons like this useful, please subscribe and hit the notification bell so you can be notified of new videos. And of course, don't forget to check out the other videos in this series covering the basics of prime numbers and how to find the prime numbers between 1 and 100. Here they are linked on screen. Well, that's it for now. Take care. Until the next time.